Hi everyone, Assalamualaikum. In this video, we are going to discuss indefinite versus definite integrals. Okay. Now we look at example for multiplication function that possible to expand. Okay. We look at number 1a, integration of 1 plus 1 over x times 3 minus 2x dx. Okay. This is multiplication functions. Okay. And the question is integrate. Okay, because we have integration sign here. Okay. Be careful. Never use product rule to integrate as in differentiation, because no product rule in integration. Okay. So from here, there is no power, or means that we have bracket to the power of 1. So it is possible to expand. Okay. So we expand this function. Okay. So after we expand, we get this. Okay. Alright. From here, we multiply 1 by 3. So we get 3 here. And then we multiply 1 by negative 2x. So we get negative 2x here. And after that, we multiply 1 over x and 3. So we get 3 over x. Then we multiply 1 over x and negative 2x. And after we simplify, we get 2 here. Okay. Alright, then we simplify again. So we have 3 minus 2 equals to 1. Minus 2x plus 3 over x. Or we can write integration of 1 minus 2x plus constant 3 times 1 over x dx. So from here, in between is plus and minus. So we can integrate 1 by 1. Okay, from this formula. If in between is plus or minus sign, so we just integrate 1 by 1. Okay, so we integrate 1. Okay, we can use this formula. When we integrate 1 with respect to x, the answer is x plus c, but we just put plus c at the end. Okay, after we done integrate all the functions. Okay, so if we integrate 1, we get x. Okay, then we still have constant 2 in front here, and then we integrate x. Okay, when we integrate x, it becomes x squared over 2 from here. Okay, and then we have multiply by constant here, so we just put constant. Then we integrate 1 over x. Okay, when we integrate 1 over x, it will equals to ln x. Okay, so we get this. After we finish the integration, we can put plus c at the back. Okay, then we can simplify 2 here. So after we simplify, we get x minus x squared plus 3 ln x plus c. Okay, this is indefinite integral, no lower and upper limit. Okay, and the answer in terms of x, if we have dx here, and must put plus c at the back. Okay, alright, let's say we have same example, but we have lower limit 1 and upper limit 2. Okay, same function. Okay, so using the same technique, okay, we get this, and then this, and then this, and then after we integrate, no need to put plus c at the back. Okay, but we put square bracket with lower and upper limit. Okay, but the step above similar to indefinite integral. Okay, for definite integral, we have no plus c here, but we must put square bracket with lower and upper limit. Okay, after that, okay, we simplify here 2. Okay, and then after simplify, we get this x minus x squared plus 3 ln x, but no plus c. Okay, and then after that, we substitute upper limit first. Okay, we substitute 2 into all variable x here. Okay, and then in between must minus, and after that we substitute lower limit 1 into variable x. Okay. Alright, then we simplify. Okay. Ln 1 equals to 0. Okay, if you use calculator. Okay. Then 1 minus 1 is 0 plus 3 times 0, 0. So this is 0. Okay. And then from here, you can use calculator. So after you use calculator, the answer is 0.07944 up to 5 decimal places. Right? This is indefinite integral. Okay, indefinite integral means we have no lower and upper limit. And the answer is in terms of variable x if the question is dx, and then must put plus c at the back. Okay. Alright, this is definite integral. Okay. Definite integral, we have lower and upper limit here. Okay. And the final answer, to get the final answer, we must substitute upper limit first, and then in between is minus, and then we substitute lower limit into variable x. Then we get the final answer using calculator. Okay. Indefinite integrals means integrating a function without any limit. But in definite integral, there are upper limit and lower limit. In other words, we call that the interval of integration. Okay. Alright, now we look at example number 2. Okay, we have integration of t to the power of 1 over 3 times t minus 1 bracket squared dt. Okay, this is multiplication function. Okay, and the question is integrate because we have integration sign here. Okay, be careful. Never use product rule to integrate because this is multiplication function. So sometimes student tends to use product rule. Okay. But this is integration, so never use product rule to integrate as in differentiation. Okay, because no product rule in integration. Okay, product rules not allowed to integrate. Okay, alright. So from here we have square here. Okay, so it is possible to expand. Okay, so first we expand the bracket square here. Okay. So after we expand, so we get this. Integration of t to the power of 1 over 3 bracket t squared minus 2t plus 1 dt. Okay. So when we integrate t minus 1 squared, we get this. Okay. We use this formula. A minus b bracket squared equals to a squared minus 2ab plus b squared. Alright, from here, our a equals to t and our b equals to 1. So when we expand, so we have t squared minus 2 times a equals to t times b equals to 1. So we get minus 2t and then plus b squared, so plus 1 squared equals to 1 here, right? Then we expand t to the power of 1 over 3 and bracket, okay? So we get this, okay? We multiply t to the power of 1 over 3 by t squared. So we can use properties of indices. If we have a to the power of m times a to the power of n, we have a to the power of m plus n. So when we have t to the power of 1 over 3 times t squared, so we have t to the power of 1 over 3 plus 2 here. Okay, so after we simplify, we get t to the power of 7 over 3 here. Okay, and then t to the power of 1 over 3 minus 2 times negative 2t. So we still have negative 2 here. Then we expand t times, we multiply t times t to the power of 1 over 3. So we get, using the properties of indices, so we get t to the power of 4 over 3. We still have constant 2 in front here. Okay. And then we multiply t to the power of 1 over 3 and 1. So we get t to the power of 1 over 3. Okay. Alright, and then in between is plus and minus sign. So we can integrate 1 by 1 with respect to t. Okay. So we integrate using power rule here. Okay. Before that, we integrate 1 by 1 because in between is plus and minus sign. So we just integrate 1 by 1. Okay. So from here, when we integrate t to the power of 7 over 3, we use power rule, okay, when n not equals to -1, because 7 over 3 means not equals to -1. So we use this formula, okay. X to the power of n dx equals to x to the power of n plus 1, means 7 over 3, we plus 1. So we get the power of 7 over 3. And then over n plus 1 means over 10 over 3. Okay. So we get this. Then we still have constant 2 here, and then we integrate t to the power of 4 over 3 using the same formula. So we plus 1 from 4 over 3 here. So we get t to the power of 7 over 3, and then we over n plus 1 means over 7 over 3. Okay. We still have constant 2 in front here. And then when we integrate t to the power of 1 over 3, 1 over 3 means not equals to -1. So we still use the same technique. Okay. From 1 over 3, we plus 1. So we get t to the power of 4 over 3, and then over n plus 1 means over 4 over 3. Alright. Okay, then. Okay, we have over fraction here, so we can change to multiplication. So we can write over 10 over 3 to multiply by 3 over 10. We just exchange the numerator and denominator. So we get 3 over 10 t to the power of 10 over 3 minus constant 2 here. And then we move 7 over 3 up here. So we get 3 over 7, yeah, times 3 over 7 t to the power of 7 over 3, plus we move fraction 4 over 3 up here. So we get times 3 over 4 t to the power of 4 over 3, and then there is no lower and upper limit, so this is indefinite integral, so must put plus c at the back. Okay, then we simplify, so we get 3 over 10 t to the power of 10 over 3 minus 2 times 3 means 6 over 7 t to the power of 7 over 3 plus 3 over 4 t to the power of 4 over 3 plus c. Okay, this is the final answer, right? When we integrate this, okay? We never use product rule, okay, but we need to expand first because squared here means possible to expand, okay? Coming up next, integration of division functions, separating the fractions. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.